it to me, and I will solve it for you, and I will record that. Now, I will start with chapter 8, which is momentum. Which is momentum and impulse. For example, the first example. Any questions so far? There's chat. Can we listen? Yes, you can. If you like, I will put your music now in the lecture if you because I like music. And the exam will be using the lockdown browser. But if you have any issue, please tell me during the exam. My phone number is with you. You can contact me by messaging. Okay, now if we have, I'm talking about the first example. I need to start. Any question before that? I need to talk here. Okay, the first example, which is exercise 8.1. What is if we have a mass equal to 12,000, 12,000 kilograms, and its velocity is equal to 13 meters per second. We need simply to find the momentum. We don't have any information if this motion is in X or in Y direction. So we will take it just in one dimension. We don't know where is it. If it is in X or in Y, it is just in one dimension. So we can solve it simply as a magnitude. It is mv, which is equal to 12,000 multiplied by 13. This will give us the answer, which is given here. By the way, these examples are put in on Mastering Physics. So you can go there and solve them by yourself. And with the same number, it will be 1.6 e 10 to 5, or multiplied by 10 to 5 kilograms meter per second. Now, if we have another object, if we have, this is mass 1. If we have M2 with another mass, which is kilogram, but with the same speed, which is this one. How much the velocity? How much the velocity? What is the chat now? Okay. Okay, now we need to find the velocity. This is the first object. This is another object. This mass is at 12,000, but this one is smaller. If we give it the same momentum, then do you expect that the velocity will be more or less if we give it this momentum for a big mass? For a small mass, this velocity will be larger because small mass. Assume that we have a big ball and a small ball, which is a big ball. A big ball. This, if this hit this one, this velocity will be high. Now we can find the velocity. V2 is equal to P, which is the same, that one, over the mass, which is 2,000. This will give us almost 71 meters per second, approximately. So its velocity much higher than this one because the difference of mass. Okay, what we have also. What about the kinetic energy? Yes. Now, we have this system with this big mass and this system with this small mass. If we take the momentum for the first mass and give it to the second mass. Now, this mass, big mass, this is the smaller mass. We give it the momentum. Then its velocity is equal to 71 meters per second. What if we give it the kinetic energy? We need to compute that. How much the kinetic energy initially? Kinetic energy initially for the first mass is equal to m1 over 2 v1 squared. Okay, this will be equal to, you need to compute it, okay? I think it will be, where's the calculator? Ah, it's here. It is half multiplied by the mass, which is 12,000, multiplied by 13 squared, it is equal to 1 million joule. What if we need to find the velocity for the second object? Now we give this object this energy. Okay, so the kinetic energy for the second object, it is the same like this one, which is 1 over 2 mass 2 multiplied by V2 squared. Now this V is different than that one. Okay. Now V2 squared is equal to 2 kinetic energy, which is this one, over the mass. We need to remove the square sign with the square root. This will be equal to multiplied by 2 divided over the mass. It will be approximately 30 meters per second, as you see in your sheets. Yes, right. This is okay. This is for the first example. The second one, I will solve part of it. If we have the system of particles, A, B, and C. C has a velocity to this direction. A has a velocity to this direction. B has a velocity to this direction. MA is equal to 5 kilograms. MB is equal to 6 kilograms. MC is equal to 10 kilograms. The velocity of A, it is to the negative y direction. You can see that. V is equal to 11.4 meter per second negative J hat. VB equal to 9.6 meter per second in this angle direction, which is 60. Theta equal to 60. We can decompose it to Bx and By. What about C? VC is equal to 3.2 meter per second to the negative I hat. Simply, we need to find the momentum for this system, for the first and the second object and the third object and so on. Okay, for the first object, PA is equal to MA multiplied by the velocity for A, which is equal to, the mass is 5, the velocity is 11.4. It is in negative J hat. Plus 0 I hat. We don't have any momentum component in Y direction, in I direction, yes. This will be equal to 2.557 with negative sign J hat. That's it. What about PA? PB, I'm sorry. This is as a vector. These chunks are okay, PB, which is equal to B has X and Y component. It is the mass, which is MB VB I hat in X direction plus MB VB in Y direction, J hat. But Vx and Vy, we can't find them. The mass is 6. V, it is the velocity, which is 9.6. Cosine 60. Cosine is in the direction of the angle. Okay? If you have any issue about that, please tell me. Is PA in the negative? Yes. Yes, it is in the negative Y direction. PA. Now, this is an I hat plus the mass multiplied by the velocity, which is the speed, multiplied by sine 60. J hat. This will be equal. This is P, B as a vector. This will be equal altogether using the calculator. 6 ضرب 9.6 cosine 60, which is half. It will be 28.8. You can see now. I hat plus all of B's momentum in positive direction plus we need to apply sign now plus 49.9 J hat. Now we found PB. What about P for C? For C, we don't have any Y direction. We just have negative X direction. 50 joule, what do we, 50 J hat, yes. It is almost 50. It is mass for C multiplied by velocity for C, which is just in I direction plus the mass for C multiplied by zero velocity in J direction. This will be equal to the mass is 10, the velocity is 3.2 with negative sign. So it will be negative 23 I hat. This is the momentum for P. C, for the particle C. Okay. If the question asks us about any thing, now we know it. Now we have three momentums. P A is equal to 0 I hat minus 57 J hat. P B is equal to 28.8 I hat plus 49.9 J hat. And we have PC is equal to negative 32 I hat plus 0 J hat. And all of them have 0 K hat, 0 K hat in Z direction. The questions in that example ask you about a system for two particles, for these two particles, for these two particles. You need just to add them together to find the total momentum each time. So if you need a system for this and this, you need to add that two momentum in Y direction and in X direction, and the same for this. I will pass. Now we did everything. Okay. I need to save time. A, we need for PA and PC. What is the X component? We need to add them together. For B, we need to, for E and C, BA and C in Y component. C, B and C, we need the X component and the Y component, and then for all of them. We can do it. Any question about that? I'll go to the next. The next example, just to find the momentum, exercise 8.5. Also, to find the momentum, I will move to a collision example. Yes. Now I'll go to sheet number, I don't know the number. Because we have another sheet, another chapter for today. Now, for example, we have collision. If we have a puck with mass M1, let us say MA is equal to 0.251. Why this one? Kilogram. And another MB is equal to 0.371 kilogram, which is initially at first. B initially is 0. And VA initially is equal to 0.121 meter per second. to the left in negative I direction, to the left, VA initially. No, we don't know. Initially, we don't know the velocity for the first object. After the collision, this is A, and this is B. VA after, finally, to the left is 0.121 meter per second, and VB, finally, to the right is equal to 0.651 meter per second to the right. Now, what is the initial velocity? Yes, what is the initial velocity? I will remind you by two equations. If you remember, for the elastic collision, we have in the condition when the second object is at rest, we have VA after, I'm talking here after. VA is equal to MA minus MB over MA plus MB multiplied by VA initially, and VB is equal to 2MA over MA plus MB multiplied by VA initially. We need to find this one. We have all these are given. We need to find VA and VA. This is after. Now, we need just to apply it. VA after, it is 0.121 is equal to the mass, the difference between the masses. It is 251 minus 0.371 over the summation of them, 0.251 plus 0.371 multiplied by VA initially. By that, you can find VA (0.841 meter per second). And I don't know about this one, but it is existing that in the example. You can find it by two ways. Okay, what else? Calculate the change in kinetic energy. Okay, the kinetic energy initially is equal to the kinetic energy for A plus the kinetic energy for B, which is equal to half MA VA squared initially plus half MB VB initially squared. But VB initially is 0. Then there is no contribution from the object B for this kinetic energy for the system in this system. Okay. Now the kinetic energy initially is 1/2 the mass multiplied by VA squared. This is the mass for A. So this kinetic energy, I'm sorry for this board, it is small. So kinetic energy initially is equal to 1/2 the mass for A. It is how much is it? Again, zero point 251. The velocity, which is that one, 0.84 squared. This is the initial kinetic energy. It will be equal to some number. Just half multiplied by 0.21 multiplied by the velocity squared, which is 0.841 squared. It is 0.0887 joules. Now, this collagen is this is the kinetic energy initially, which is the same. If we move this decimal point, it will be 8.87 multiplied by 10 to minus 2 joules. Now, again, you can find the kinetic energy finally, which is equal to kinetic energy for A plus the kinetic energy for B after the correction, which is equal 1/2 MA BA squared after plus 1/2 MB VB squared. After the correction, you will have another number. Now, the change in kinetic energy, it is not fully elastic collision. Now, the change in kinetic energy will be kinetic energy finally minus kinetic energy. Change in kinetic energy for which particle? Calculate the kinetic change in kinetic energy system. Initially, this will give you a small magnitude, which is negative. There is a lost kinetic energy, 8.36 multiplied by 10 to minus 3 joules. The change in energy is negative, so we have lost kinetic energy. And this example or this system is not fully elastic. Okay, what is the next one? How much time now? Okay, we can solve just one example about the momentum. I need to give more time for rotational motion, because in general we are good in linear motion problems. Okay, now we have to push each other, two person on icy skiing yard. Now they push each other to this one to this direction and this one to this direction. One of them, its weight M1 is equal to its weight over G. We need to know the mass, and the question give us the weight. The weight is equal to 755 newtons over G. This is the mass for the first one. The second one has a mass is equal to his weight, which is 655 over G. We need the mass, we don't need the weight, okay? Now, initially, their momentum, P initially is equal to 0. Then P finally, after they go away from each other, finally should equal to 0 also. Okay, we have a mass and velocity for the first one, and we have a mass and velocity for the second one, which is the momentum, and their momentum should be equal because one of their momentum, P1, is equal to positive in x direction, and the second momentum is negative to the negative x direction. Now, P1, P initially equal to P1 plus P2. Because their velocity is equal to 0, then the momentum is 0. Now here we need to apply that equation. P1 is equal, or P initially is equal to 0 and is equal to P finally, which is equal to the first momentum, P1, plus the second momentum. So 0 is equal to P1 is M1, V1. M1, we don't have the mass, we have the weight, which is 755 over G. This is the mass, because the weight is the mass multiplied by G, multiplied by velocity. V1, is it given or not? Yes, the heavier mass, which is 755, it is more than 655. Its velocity, his velocity is 1.5 plus the second one, mass is 655 over G multiplied by the velocity. We don't know how much the velocity now. We need to find it. We'll move now one term to another side, then it will be with negative sign. It is negative 655 over V multiplied by V2 is equal to 755 over G multiplied by 1.5. Now we can cancel G from both sides. So you can see the solution in this way. Simply divide over this argument. V2 is equal to 755 over negative 655 multiplied by 1.5. It will be equal to 1073 to the negative x direction. We need to give it a negative sign. We don't have negative sign here, but it is mentioned. I think it will be mentioned that to the negative x direction, meter per second. Now, how much the kinetic energy created? Now, this is just like a collision, but going back in time. If we reverse the time, then we have a motion to the initial point, which is this one. And then they will stick. This is a full inelastic collision in this way. We have two things. We have full elastic collision. We have many masses. We'll combine just one mass. This is full inelastic collision. But what if we reverse the arrows? We have this experiment. This is an explosion, just like the fireworks explosions. It is the same as inelastic collision. we have one object divided to many objects. And we can apply the collision relations on explosion. Now this is just like an explosion. The kinetic energy initially is equal to 0 because the velocities are 0 for both of them. What about the kinetic energy later? Kinetic energy finally is equal to first one kinetic energy plus second one kinetic energy. This will be equal to 1/2 m v1 squared plus 1/2 m2 v2 squared. We have the masses. Half is a constant. The velocities, we have them. We have 1.5, 1.73 with negative sign, but the negative sign will be positive after squaring. Then the total kinetic energy finally this is V2. We use it here. The mass is given. The mass is given. V1. This is V1. The kinetic energy will be equal to 187 joules. What is the change in kinetic energy? The change in kinetic energy, it is K2 minus K1. K1 is 0. K2 is this. This minus 0, it is the same as the second kinetic energy. Is that clear? You can't shake your camera or you can say anything. Okay. Now, what else? That's enough for momentum. And you can see many examples are solved and with hints, with the discussion. And you can, I have trust in you, you can do it. And please, anytime, if you have any question, just send it to me and I will solve it. And I am sorry, I didn't have any time to solve and record any thing in the vacation. I didn't finish even my duties. Okay, what is the next routine?